Hello, and welcome to the start of Chapter 11. And in this chapter, we're going to talk about three-phase circuits. Three-phase circuits are critical to our modern power infrastructure. This is the method by which we generate power, transmit power, distribute power, get power into your microwave or into your dishwasher. This is what we use to build that infrastructure with. So in this first lecture, we're not going to work any examples. We're not going to do any real analysis. We're just going to sort of talk about what three-phase means. We'll talk about how we can hook them up. We'll talk about Y configurations, delta configurations. We'll talk about what we mean by phase sequence, where there's a way to hook it up in one way and then there's a way to flip it over and have your voltage sources be in a different way. We'll talk about what those means. So this lecture should be pretty quick, pretty easy, just to kind of get us warmed up. And in the upcoming lectures, we'll actually do some analysis and dig into some specifics and do some cool stuff. So without further ado, let's go ahead and get into it. So the primary purpose of three-phase voltage and voltage sources specifically are to generate and distribute power. This is the primary mechanism by which our sort of modern power distribution systems work, right? It goes from the power plant through the transmission lines into your house, and it's three-phased voltage that accomplishes that. And the gist of three-phase voltage is pretty simple. We have on one end a three-phase voltage source, and on the receiving end we have a three-phase load. And those guys will be connected to each other by, you guessed it, three individual lines. And each of these lines gets a name. We'll call the first one the A phase, the second one the B phase, and the third one is the C phase. And what makes it special is that all the phases are exactly 120 degrees out of phase with each other. So we have that our voltage phasor for the A phase is equal to whatever that magnitude is, V sub m, at 0 degrees volts. And then our VB phase is equal to V sub m at not 0, but minus 120 degrees volts. And our C voltage phasor is also Vm, but it's going to be at plus 120 degrees volts. Now, when the voltages are arranged this way, we refer to this as a positive phase sequence. Sometimes you'll also hear it referred to as an ABC sequence. And if there is a positive phase sequence, it sort of stands to reason that there ought to be a negative phase sequence. And there sure is. In the negative phase, VA is still the anchor point. VA is Vm at 0 degrees, but VB and VC are flipped. VB is now at plus 120 degrees, and VC is at minus 120 degrees. And this is, like I said, a negative phase sequence. Sometimes also called an ACB sequence. And one last fact about the voltage phases is that they all add up to 0. So VA plus VB plus VC
equals 0 volts. And the same is true for the time domain instantaneous voltages. So little VA of t plus little VB of t plus little VC of t also equal to 0 volts. And because of this, we can figure out everything we need to know about the three-phase circuit if we know which sequence, which phase sequence, positive phase or negative phase, which sequence is being used, and only one of the voltages. All we need to know is what sequence is being used and one of the voltages, and we can figure out everything else that we need to know about our circuit. Now there are two ways to connect three-phase sources, or connect a three-phase source. The first one is called the Y. And this looks like, or that looks like this. There's a common neutral node that we'll call in, and each of the voltage sources branch off. So we'll have our VA, and that's going to connect to our A node. Then we'll have another voltage source. Notice that we're going from negative to positive as we move away from the neutral node. That'll be our VB. And our third and final source, I'm really terrible at drawing. That'll be our VC. And that will connect to our C node. So there we go. There's a Y configuration. Now, in the upcoming lectures, we'll also consider the impedances of each of these sources. But for now, just know the Y connection, all of the voltage sources branch out from a single common node. And the second one, I bet you can guess what it is the delta configuration. And in this one, everything forms a triangle. So we have one voltage source connected in a triangle to the next voltage source. Notice that they all line up from their minus to positive sides. Ooh, that's bad. All right, then we have our VA is connected to VC, is connected to VB. Just like that. And we lay out the nodes based on the positive terminal that's connected. So the node that's connected to the positive terminal of VA and the negative of VC is our A terminal. The node that's connected to the positive of B and the negative of A is our B terminal. And the node that's connected to the positive of C and the negative of B is our C terminal. So that is the delta configuration. And we can connect the sources and the loads both in Y's or deltas. So we get a table here that lays out all of the combinations. So we can have a Y source connected to a Y, not delta, what did I write delta up there? Source and load. So we can have a Y source connected to a Y load. We can have a Y source connected to a delta load. We can have a delta source connected to a Y load and a delta source connected to a delta load. And in the upcoming two lectures, we'll do some analysis on the Y configuration and the Y delta configuration. But we won't really worry too much about the delta to Y or the delta to delta, although they do exist and have their merits and drawbacks.
All right, so there we go. Quick and easy. Like I said, no examples, no hard work. We just sort of went over the basic fundamentals of what it means for a circuit or voltage source specifically to be in three phases. We talked about positive phase sequence, talked about negative phase sequence. Remember, it's 120 degrees out of phase in either direction from VA. And we talked about how to look at the Y configuration, where they're all connected, branching out from that common node, that common neutral node. And we talked about the delta configuration, where they form that sort of weird triangle of voltage sources. So that's it for this lecture. In the next one, we're going to talk about the Y to Y configuration. So we're going to analyze a circuit in which we have a source, a three-phase source that is on a Y configuration that's attached to a load that's in a three-phase configuration. So as always, if you have any questions, comments, or concerns, please let me know. And if not, I look forward to seeing you guys in the next lecture. Thank you.